Good afternoon. Let's start. What was the last part we did in the last class? Yes.
So we should start from disproportionation reactions.
Of halogens, no? Oh, yes.
Yeah, I mean,
Yes.
no, I think that in the page 3.
Yeah, that is sitting group.
Yeah, group 7. Yeah.
Yeah. Few more I get to come, no? This part, disproportionation, can you tell me the definition for the disproportionation? Senal, can you tell me the definition for the disproportionation? How to define disproportionation?
A reaction with involving both oxidation and reduction for one species.
Yeah, same species undergoes oxidation and reduction. Right. So, group 7 elements, or you can say halogens, will undergo disproportionation reaction. So, the first one is there is chlorine with water, number 1. Yes. This is the example. This is how you can identify whether the reaction is disproportionation or not. Just check whether one element is appear in 2 products. And if it is so, you can check the oxidation numbers. So 0 to -1 reduction, 0 to +1 oxidation. This is a typical exam question they will usually ask in this case. Right, in this case, chlorine undergoes reduction as well as oxidation. You have to show the oxidation numbers and the change in the oxidation numbers as well. Finish copying. Okay, next example. Example number 2. Chlorine with this produce important chloric 1 acid. It's has power to kill the pathogens. Next one, chlorine with cold alkali. Chlorine with cold alkali. And again, sodium chloride, sodium chlorate 1 is formed. So 0 to -1 and 0 to +1 is the change in oxidation number. Done. Next one, chlorine with hot alkali. Next one, the next reaction, chlorine with hot alkali. This one. There, chlorate 5 is formed. And remember, by heart this reaction with the balancing figure as well, because this is a common question again. Right. And remember, bromine and iodine also react in similar way. Therefore, you can say that group 7 will undergo disproportionation in the presence of cold alkali as well as the hot alkali. And the next part is important, predicting properties of the elements that you haven't learned, that is fluorine and astatine, right? Fluorine is above chlorine and astatine is below iodine, right? Therefore, following the trend, you can predict the properties, right? That means fluorine can displace chlorine from a compound, iodine can displace astatine, like that. You should be able to work them out. Next, most important reaction. Topic is reactions of halide with sulfuric acid. Reactions of halides with sulfuric acid. Halides mean Cl minus, Br minus, I minus. Right? So up to now we have discussed about the reaction of halogens, Cl2, Br2, I2. Now we are discussing halides. Topic reactions of halides with sulfuric acid. And you must know this how the oxidizing power and how the reducing power changes with the halogens and halides. So remember, fluorine is the most powerful oxidizing agent and astatite is the most powerful reducing agent. But since we are not talking about the fluorine and astatine much, for our syllabus, you should know the chlorine as the powerful oxidizing agent and the iodide as the powerful reducing agent. Finish copying?
Yes, sir.
Where's this Shanil? This part. If you can't understand, just let me know. Right. This is how halide undergo oxidation. If it undergo oxidation means this is how it acts as reducing agent because itself oxidize and reduce the other species. Copy this one. So we are going to talk about reactions of this halide with sulfuric acid, right? Sulfuric acid behaves as an acid, right? Not only acid, and sometimes behaves as oxidizing agent, right? Sulfuric, then write down sulfuric acid is acid, but when concentrated, it contains few ions. And this one. And when concentrated, portion of the equilibrium lies to the left. You know these terms, right? Portion of equilibrium. Copy this one.
Sir,
Yes. Honey.
now
කොහෙද හිටියේ?
කොහෙද හිටියේ කියන්නේ අර අපි මීට කලින් ක්ලාස් එකක් තියන්නේ.
ආ.
ගෙදර එන්න ඔන්ලයින් එක.
හරි තාම ලොකුවට පටන් ගත්තේ නෑ. It's okay.
මේක ලියන්න ඕනද?
ඔව්. Yeah.
මොකක් ගැන දෙන්නේ?
රූල් 10ක් විතර ඉඳලා මේක ලියන්න.
මේකෙදි print out එක
Wait. Mike Benin. Sorry, I forgot to show it.
අපි අන්තිමට ලිව්වේ disproportionation reactions එක අර with water with
ඒ reaction ඔක්කොම අපි ලිව්වා.
ඔව් ඊට පස්සේ reactions of fluorine and astatine
ඒකත් ලිව්වා.
ඊට පස්සේ තියෙන්නේ halide salts NaX KX H2SO4 Na
ඉන්න මම පෙන්නන්න. wait. ඒක තමයි මේ කරන්නේ අපි දැන් reactions of halide ions with concentrated sulfuric. අපි මෙන්න මේ ටික තමයි ලියාගත්තේ. අපි now මෙන්න මේක ලියාගත්තා. Now we are here.
එතකොට under that did sir give points
that කියන්නේ අපි මේකේ I ask you to write this part. Sorry. I ask you to write this part and this. Right? Shall we move?
Wait. Okay, sir.
Very good. Then write down, when concentrated, sulfuric acid can act as oxidizing agent as well as acid, right? And the extent of reduction, that means itself reduce, no? That extent of reduction of sulfuric acid depends on
Wait, can you repeat it like
okay, I'm repeating again. So sulfuric acid undergoes now sulfuric acid behaves as acid as well as oxidizing agent when concentrated. So the extent of reduction. So in order to oxidize someone, sulfuric acid should be reduced, no? Right? Extent of reduction depends on the species being oxidized, right? So you have three possible reduction products with sulfuric acid. Those are sulfur dioxide, sulfur, and hydrogen sulfide.
the extent of reduction.
Depends on the species being oxidized. So the extent of reduction depends on the halide use. Okay. So to act as oxidizing agent itself reduce, the extent of reduction depends on the species being oxidized. Here it is the halide ion. Okay. Right. Now this reduction can be shown by using three equations. That means to forming the three different products. The first one shows how the sulfur dioxide has formed. Second one, how the sulfur is formed. And the last one, how the hydrogen sulfide is formed. Right? So important of this is now, look at this. In sulfuric, sulfur is in +6 oxidation state and reduced to +4. Or else +6 to 0 and +6 to -2. That's how it goes.
So it can be -2, -6, එහෙම නැත්නම් මේ -8.
Change. Yes.
Yeah, the change. It can be either 2 change, 6 change, or 8 change.
Okay. Copy.
මේක නිකන්
Clear.
Okay.
We are going to discuss these reactions with sulfuric and the halide ions. Okay. Now, when you react concentrated sulfuric acid with sodium halides, following observations can be made. So that is already printed in your book. Therefore, you don't have to write it. Yes. Now look at this. When in, and now write down on top of the table, right? When the typical observations of, typical observations and the products formed when,
So can you repeat, please?
typical observations and products formed when concentrated sulfuric acid is added to sodium,
Let's.
when concentrated sulfuric acid is added to sodium halides. Right? So now, those who don't have the table, you can copy, right? With NaCl, you can observe only misty fumes. Reason is the production of hydrochloric acid. With NaBr, misty fumes, brown fumes, and the colorless gas with choking smell can be observed. Misty fumes because of HBr, brown gas, that is Br2, colorless gas with choking smell is SO2.
දැන් මේ ඔක්කොම මතක තියාගන්න ඕනද?
මම මතක තියාගන්න ලේසි දෙයක් කියලා දෙන්න. With sodium iodide, misty fumes, purple fumes or black solid, which is iodine can be formed, which is iodine, misty fumes is HI, colorless gas with choking smell SO2, yellow solid, sulfur, and the colorless gas with rotten egg smell is hydrogen sulfide. So, with sodium chloride, only HCl, that means no reduction product of sulfur is there. But with sodium bromide, you have sulfur dioxide as the reduction product of sulfuric acid. With sodium iodide, you have sulfur dioxide, sulfur, and hydrogen
HCl.
sulfide. Right? That means sodium bromide will produce sulfur dioxide, but sodium iodide can produce all the three reduction products. Is this clear?
Yes.
Okay. Those who need to copy, you can copy this now quickly.
What's the easy way to remember?
Easy way. Just wait. have to use some more papers, right, to write this. Write down the subtopic. Reactions of sulfuric acid. Reaction of sulfuric acid with sodium chloride. Reaction of sulfuric acid with sodium chloride.
මේක ලියන්න ඕන වෙන paper එකකට.
Paper එක ලියලා ඔයා attach කරගන්න වෙනවා ඒක. And you can write this equation. ඔච්චරයි.
ආයෙ අර topic එක පොඩ්ඩක් කියන්න.
Reaction of sulfuric acid with sodium chloride.
ඊට පස්සේ මේ equation එක නේ.
Equation එක ලියන්න. Yes.
හරි.
Right. එතකොට here chlorine -1, -1, sulfur +6, +6. So no change in the oxidation number. Therefore, there's no redox reaction, right? Then write down. With sodium chloride, the sulfuric acid behaves only as an acid.
Okay.
And not as oxidizing agent. And not as oxidizing agent. Right. Right. Now, ඊට පස්සේ the next one මම දැන් කියලා දෙනවා the easy way to remember. Right? Then sodium chloride will react with sulfuric acid to form sodium hydrogen sulfate plus HCl. Similarly, sodium bromide react with sulfuric acid to form sodium hydrogen
Bro.
plus HBr.
Yes.
So good. And also NEI react in the similar way to form NaHSO4. But
ඉතින් එතකොට අර ඉස්සල්ලාගේ බ්‍රෝමීන් හැදෙනවා කියලා තියෙනවා.
right. So all three sodium halides react with the sulfuric acid to form steamy fumes. Matakane first observation. So steamy fumes because of HCl, HBr, HL.
Yes.
Right? Then we just wrote this 3/2 equations about sulfuric acid. Okay.
Yes.
Now with bromine, the produced HBr then react with sulfuric acid. That is a produce HBr will react with sulfuric acid. Right? So the reaction is this one, H2SO4 will reduce to another yes, 2H plus 2 electrons, giving H2O and SO2.
Yes.
2H2O and SO2. So this reaction and Br minus this. So this is the oxidation of, I told you, if sulfuric acid reduce, Br the halogen, so halide will oxidize. That's why sulfuric can act as oxidizing agent. So by combining these two, we can write H2SO4 react with 2H plus and 2Br minus, forming SO2, Br2 and 2H2O.
2H2O.
Clear? Right. Forming SO2, Br2 and 2H2O. We'll write this in detail, don't worry. I'm explaining. Okay. Clear?
Yes.
Similar reaction will be obtained with HI as well. Forming SO2, I2 and 2H2O. Clear? Right. Then we method make first we write this part. Then we'll come to ID. Okay. Then write down the reaction of sulfuric acid with sodium bromide. First reaction, similar, and write down, similar to sodium chloride, it forms
Wait, so this comes under reaction of sulfuric acid with sodium bromide.
Yes, yes. Similar to sodium chloride, sodium bromide also produce misty films of hydrogen bromide. Then you can write the first equation. Okay, then next point, the produced misty films of hydrogen bromide, the produced misty films of hydrogen bromide will be oxidized by sulfuric acid. And then you can write yes. But you know, the everything together, right? This shows everything how it forms. Finish writing?
Sir, one more minute.
Finish writing?
Yes, sir.
Right. Done. So the observation that is different from the sodium chloride is this: sulfur dioxide is a gas with choking smell, right? Now we
Now next
discuss
is reactions of sulfuric acid with
sodium
So-
iodide. ඉතින් මේක ඉවරයි, මේ දෙකම ඉවරයි. දැන් අමතක නෑනේ. Can remember now?
yes.
Can it? Right. Then by looking at this, then sodium iodide will react similar to the sodium chloride as well as to the sodium bromide. Okay? And the first two reactions are same. We'll write those two first. Then write down reaction of sodium iodide with concentrated sulfuric acid. All the time this is concentrated sulfuric acid. Huh? Then similar to sodium bromide, sodium iodide also forms sulfur dioxide and misty fumes. Of hydrogen iodide, and also purple fumes of
Fumes of iodine.
Iodine.
or iodine.
yes. And it's similar to that, right? And did I mention anything regarding sulfur dioxide as well? Yes, ne? Okay.
Yeah.
Now, write these two equations. This one misty fumes. This one sulfur dioxide gas with shocking smell. Grey solid or purple fumes. Right. Done. Then write down. Iodide is more stronger reducing agent. Therefore, the reaction, and therefore it produce yellow solid sulfur as well. Now here it represents how the yellow solid sulfur has formed. Here HI react with H2SO4 again for the reaction, forming sulfur plus iodine plus water. Another reaction. So sulfur also formed. So this is nicely explained here. See, iodide will oxidize and sulfur will reduce. And they are joining these two half equations and they have written the balanced equation. Clear?
Yes.
Now you can write this one as well. Finish writing.
Wait. Okay.
Right. Then next point, write down. Iodide ions are still stronger. Iodide ions are still stronger to reduce sulfur in sulfuric acid. Sulfur in sulfuric acid. To hydrogen sulfide. This equation changes. We have to replace this by the last equation. That means where it forms the hydrogen sulfide. Sorry. Where it forms the hydrogen sulfide. H2SO4 plus 8H plus 8 electrons gives you H2O plus H2S. Did I came because it's something wrong? The man may have to balance this. Sorry.
Should be 4, right?
Where?
H2O එක ළඟ.
H2O ළඟ 4 ඉන්නේ. පොඩින් පොඩින් අපි balance equation එක මේක පාර. I'll tell you how to balance this even. We know how to balance this name. Right? So H2
H 4 නෙමෙයි දෙන්න ඕන.
in balance. H2SO4 produce H2S. Here 4H2O, then 4H2O plus 8H plus 8 electrons.
8 electrons.
Now it balances, yes. Then these two equations. So what you have to do is you have to multiply the equation, this equation by 4 and add it to this. You got it?
Yes.
H2SO4 plus 8H plus 8I minus gives you
H2S
H2S
plus OH2O
4H2O plus 4I2.
5.
Okay. Great. Then the final equation, you can write H2SO4 plus
8HI
8HI gives you H2S 4H2O plus 4I2. Now let's write this one.
Okay.
Yes.
Right. But I'll go for my make it hidden and H2S. So I don't think you can see this. So the final product H2S also there. Right? So first reaction, this means these three are same, these two are same, the last two is the only difference. So you can by heart the last two equations. That's it. So this shows that iodide is the stronger reducing agent because then when you compare Cl minus, it's not a redox reaction, but Br minus forms Br2, sulfur dioxide goes, sulfuric goes to sulfur dioxide. So the change in oxidation number is +6 to +4. But with I minus,
It should be +6 to -2, right?
gives, yes, I2 is SO2, S and H2S. All are possible. This is 0, -1 to 0, but sulfur +6
To -2.
+4, yeah, +4, 0 and -2, all are possible.
-2.
This shows that iodide is stronger reducing agent. Remember, this reaction is very important because it's a combination of redox reactions and observations and writing the equations, balancing everything. Therefore, this will be asked in paper 3 as well. Clear? Right. Right. Now, I'll show the practical video for this particular experiment as well. Halides with concentrated sulfuric acid. Can you all see the screen?
Yes. Yes.
Can see, right? Here we go then. Now I'm going to play this.
Now I've got in these test tubes 3 pretty similar looking white solids. The first white solid is sodium chloride solution. Sorry, sodium chloride solid. The middle one is sodium bromide. And the last one, the third one, is sodium iodide. This reaction is with concentrated sulfuric acid, which is just over there in the tray. Right, here we go. I'm going to add sulfuric to all 3, and we're just going to watch. Ready? Sodium chloride. A lot of gas being made. Yeah. So we think that gas is chlorine. Reasonable guess? Yeah. I'm just going to get some damp blue litmus paper. Damp blue litmus paper, here we go. That was put into the gas and it's gone red. So the gas was, yeah, and the identity of the gas, HCl. Do you want to put the fume cupboard on? Press fan. Press fan. Yeah. Right, the second one. The sodium bromide. Let's watch this go in. Really close. Again, fizzing. Right? Once again, fizzing taking place. Yeah. So white fumes coming out. The white fumes turning the litmus paper red. So the white fumes are HBr. But this time we've also got, which is, remember it was concentrated sulfuric and it's bromine. So this time we've got HBr and bromine. The reaction of consulfuric with sodium bromide is more complicated. The sodium chloride just gave us HCl, that's it. But the sodium bromide is giving us HBr and bromine. The third one is going to be even more complex. So, concentrated sulfuric acid into the sodium iodide, fizzing away, and it's all of a sudden gone very dark. So have we any idea what that is? We've actually made in there a very dark solid. It's iodine. We've made iodine. People close by, it smells like eggs. So there's a smell, a very bad smell of eggs. Yeah, open the window. Do we know the name of the gas? Hydrogen sulfide, it's H2S. Now let's see if we can get this right on video. What's the oxidation number of sulfur in sulfuric acid? Plus 6. What's the oxidation number of sulfur in H2S? -2. We've got a huge change from +6 to -2. A shift of 8 numbers. What's happened to the sulfuric acid? +6 to -2, the sulfuric acid has been reduced. Yeah, and that's a heck of a reduction. Yeah. So what must have happened elsewhere, there must be a huge oxidation going on. A huge oxidation.
Is this clear?
Yes, sir.
Let's do a past paper question. Okay, so this entire question, everyone can see, no? So this entire question will be having altogether 8 marks, right? Therefore, I'll be giving you only 8 minutes. So 1 mark for 1 question, right? So I'll be changing the question accordingly. Right, okay. Let's start. Now the time is 2:56. And within 8 minutes, you have to finish this. Can everyone see the screen?
Yes.
Okay, good.
It's only the question A and B, right?
නෑ full question මම මාරු කරන question වෙලා ඉවර වෙනකොට Last question and the last minute. Right. Time's up. So how's the question? Can man easy or difficult?
Yeah, first parts are like easy.
මේවට වඩා අමාරු questions ඉන්නේ. This is again for your reference. This is 2010. Okay, no, ඕගොල්ලෝ දන ගාන කාලේ වගේ paper එක. Right. Okay, but anyway, for your reference, I'll be sending this question to the group. By the way, did you manage to finish the question within the given time? Hands up. Who did
Yes,
manage?
for the yeah, I finish.
Others name the kawuruth. Only Sonali.
The last one I couldn't do.
Hari
But
comment
I-
but this is the trick. Always only two. Only two of you manage to do within the time. ඒක තමයි ඊළඟ වැඩේ. You have to keep eye on the timing as well. Remember, 1 mark scores 1 minute. Right. After this month, the papers I'll be giving on every Wednesday will be more towards the past paper pattern. Sometimes mostly the past paper questions. Right. And always remember that 1 mark will be 1 minute. Right. So you have to answer within the given time. Right. Okay. Hari. Let's continue. When chlorine is added to solution containing bromide or iodide ions, a color change occurs. What solvent would you add it to the mixture to confirm the identity of halogen produced? Can I know the
Silicon
answers? මොනවද දාන්නේ? කියන්නේ බලන්න උත්තර. Siliconitrate.
Silicon.
තා මොනවද උත්තර? Anything else? Who's going with silonitrate? 1. Tricky, very good. Yep. Go up. Ahalian, what is the answer? Ashen, what do you think? Heshan, what is your answer? Yes. Tamesh, what do you think? If you said silonitrate, that's wrong. Unfortunately, they are asking about identity of the halogen produced.
So is it sulfuric acid?
No. Halogen. You are adding Cl2 to solution with Br minus or solution with I minus. So it produced Br2 or I2. So the color change can clearly see if you add an organic liquid. We did this. Iodine will be purple. inorganic solution. Therefore, any organic solution, most probably carbon tetrachloride or hexane is the answer. So if bromine produce, solution turns brown. I can say an alkane, right? Because gaseous alkanes are there, no? Right, so done. Show by the show by using oxidation numbers. Sulfur, that sulfuric acid has been reduced. So, can I know one of your answers? So then I can say whether you have done perfectly or not. Can one cover anything? Sonali, can I know your answer? Okay. So the answer is sulfur in sulfuric acid is reduced to +6 to +4. Right?
Yes.
+6 to +4. Right? Sulfuric acid. Sulfur in sulfuric acid is +4 and it reduced to sulfur dioxide, which has oxidation number of +4. Then you have to mention the right these two together. Okay. Next one, state two observation which differ from those with the potassium bromide when potassium iodide is added. Now, what are the two different observations? Yes.
Can we say choking smell?
Choking smell, it's already there. No, rotten egg smell.
Ah, yeah, rotten egg smell.
Rotten egg smell, purple vapor of iodine, and also yellow solid of sulfur. Right.
Why iodine?
Another.
Iodine?
Sorry.
You said.
Yes. Sometimes they will ask what are the state two products that observe to reduce product. If they say write to reduce product, if you write iodine, that's wrong. Because iodine is not the reduced product. Iodine formed from oxidation of iodides. Therefore, be careful.
So can you repeat the two observations?
Two observations mean that in this reaction, in addition to bromine, so you can see purple vapor of iodine, rotten egg smell of H2S, and yellow solid sulfur.
Okay.
Okay. Right. Done. One product of the reaction with potassium iodide is hydrogen sulfide. How does this show that the iodide ion is more powerful reducing agent than bromide ions? Bromide ions will reduce sulfur from +6 to +4, whereas iodide ions will reduce sulfur from +6 to -2 in sulfuric acid. Right? Done. In areas where natural consumption.
Wait. So bromine is +6 to +2.
+4.
Wait, +4. Sorry, yeah, +4, and iodine is +6. Iodide.
Light can reduce. Plus 6 to
Alright.
minus.
Yeah.
In areas where the natural concentration of fluoride ions in rocks is low, some authorities add fluoride to water supply to improve the dental health of children. Alternative would be supply of free fluoride tablets. මොනවාද මේක ලිව්වේ උත්තර? Yes. Anna, yes. You people should have the choice whether to take or not. It's like මොනවාද vaccine එක ගන්නවද නැද්ද වගේ තමයි. Okay. Never mind. තාම හරි කිව්වොත් මාවත් මුදේ පාවේ. Right. We'll go to the next topic then. Other reactions of halides. Other reactions of halides. Number 1, testing for halides ions. Testing for halides ions in solution. Right. So this is the table. We did exactly this thing in O-levels as well, but methanadi we are doing something in addition, because in O-levels we just add silver nitrate and nitric acid, right? We observe the white cream yellow precipitate only. But after that, you have to add dilute ammonia. Only silver chloride precipitate will dissolve, not silver bromide, not silver iodide. And then you can add concentrated ammonia. Silver bromide and silver chloride will dissolve, not silver iodide. So this is how you identify the chloride, bromide, iodide ions. Remember, all 3 ions are colorless. These are halide ions. Copy this.
So in this, what's the main topic?
Reactions of halides, and there the subtopic is testing for halide ions. Reactions of halides, subtopic is testing for halide ions.
Okay.
Down the group solubility name. No. It just with this. Anyway, the silver halides are insoluble.
Iodide is soluble with chloride ions.
No. Except silver. Okay, this one also I can show using a video, right?
Here we have halide salt solutions. The first two contain the same solution, namely sodium chloride solution. The next two both have sodium bromide solution, and the next two have sodium iodide solution. I'm going to add silver nitrate to each of these. I've taken some silver nitrate in a syringe here. Let me add a few drops. The first two will give an identical result, white precipitate. These are both iodides. We get an off-white precipitate, or sometimes described as a cream precipitate with the bromides. And with the iodides, we get a yellow precipitate formed.
Then lamai in O levels we learn you add silver nitrate, white, cream, yellow. Now can you differentiate white, cream, yellow in these kind of cases?
No.
No, and that's why we have to use the further test. That means adding dilute ammonia and adding concentrated ammonia.
Let's add a bit more to get a good amount of precipitate in each case here. The bromides and the iodides. So in this particular test we see with silver nitrate, the silver nitrate has been acidified with a few drops of concentrated nitric acid. We get a white precipitate with the chlorides, an off-white or cream precipitate with the bromides, and we get a yellow precipitate with the iodides. Hoping that's showing up clearly enough. The chlorides and the bromides now have formed silver chloride and silver bromide. These are light sensitive, and as you watch it you should see these begin to darken. The silver iodide is not light sensitive and will remain yellow. So here we have colours showing up the presence of chloride, bromide and iodide, helping us to distinguish between them. Just hoping that the colours are showing up clearly enough here. We can try to turn it somewhat to the side. Chlorides, and it should be white. The next two are the bromides and should be cream or off-white, and the last two there should be yellow. So I'm hoping you can spot the difference between the white, off-white and yellow. But we can improve upon this test by testing the solubility in ammonia, and this is why I've done these in pairs. To the first chloride I'm going to add dilute ammonia to see if the precipitate silver chloride will dissolve in dilute ammonia. I'll do the same to the first bromide and the first iodide to see if the silver halide is soluble in dilute ammonia, and then I'll add concentrated ammonia to the second chloride, the second bromide and the second iodide. So let's add dilute ammonia first of all. It would be better to remove some of these so that we have less precipitate in each case. So here we've simply reduced the volumes, but we have 2 chlorides, 2 bromides and 2 iodides. Silver chloride, here we've got silver chloride, silver bromide and silver iodide. All that I've done is empty out quite a lot of the suspension. I'm going to add now dilute ammonia, testing to see if the silver halide is soluble in dilute ammonia that I have here in the syringe. So here's the first one. Let's have a look to see if the chloride dissolves in dilute ammonia. And I think you can see there that it has completely dissolved. We have a colourless clear solution there. I'm going to check to see now if the silver bromide here dissolves in dilute ammonia. And I think you can see it's still cloudy. It has not dissolved in dilute ammonia. Let's check if the silver iodide here dissolves in dilute ammonia. And again, like in the case of silver bromide, the silver iodide has not dissolved in the dilute ammonia. I have in this syringe now concentrated ammonia, so I'm going to take the second chloride here, see if it's soluble in concentrated ammonia. One would expect that it should be, given that it dissolves in dilute ammonia. You can see clearly there that it is completely dissolved. The second bromide, silver bromide, remember, did not dissolve in dilute ammonia. Let's see if it dissolves in the concentrated ammonia here. I hope you can see there it has indeed dissolved in concentrated ammonia. And lastly, let's check to see if this second silver iodide dissolves in concentrated ammonia. I've added quite a large volume there. And the silver iodide has not dissolved in concentrated ammonia. So there we have a combination of reactions to help us distinguish between the halide salts in solution. The chloride formed a white precipitate of silver chloride, which dissolved in both dilute and concentrated ammonia. The bromide salt formed silver bromide, which was an off-white or cream precipitate. That precipitate did not redissolve in dilute ammonia, but it did dissolve in silver bromide. Silver bromide did dissolve in concentrated ammonia. With the iodide we got a yellow precipitate. The yellow precipitate did not dissolve in either dilute or concentrated ammonia.
Is this clear?
Yes.
So we did
Yes.
2 practicals as well today. 2 practicals along with the theory. Okay, that's it for today. Hope you have get everything. Thanks for participating and thanks for viewing everything. Okay, bye. God bless you. Then I'll upload the recording soon.
Yes, sir. God bless you, sir.
Thank
Okay.
you,
Thank you,
sir.
sir.
God bless you, sir.
Thank you, sir.
Okay.